Hey everyone, what's up? It's Mr. Fager coming at you for the first day of action here in our virtual tour of Algebra 1. Today we're going to be looking at slope of a linear equation, but before we do that, here we have our virtual warm-up 1. Now I'm not going to do the whole thing here for you because this is as much a test to see how you're coming along with these skills as just about a quiz is. Although quiz is a lot more focused, this is something that you can work on just a little bit more, use your notes, use a calculator. I just want to see how you're coming along with this. To give you an idea of what you're looking at, really, the virtual warm-up 1 is just over solving equations and even some inequality, number 4. And to get you started with this, just remember that to solve for a variable, you just need to get the variable by itself. So in the case of number 1, I got to get that t by itself. That means I have to get rid of the positive 7 and the positive 3. Well, in that order, too. I have to get rid of the 7 because that's the constant. And how do I do that? I'm going to subtract it. So I subtract 7 from both sides. 3t is now equal to negative 8 minus 7. That's negative 15. And I got to get t by itself, so I got to get rid of the 3. Well, that's multiplication there. So I'm going to take both sides and divide it by 3. The 3's cancel out on the left, so t is equal to negative 15 divided by 3, negative 5. Now that's the only one I'm going to do for you because the rest of these are very similar to that. Number 2 is almost directly similar. Number 3 just involves an extra step. And number 4, of course, is the inequality, like I said. Nonetheless, I look forward to seeing how you do on this. And please make sure you submit this in Canvas as it is for an assignment grade. So we're going to go ahead and get started on our notes today. We're talking about slope. What the heck is slope? Well, let's define it first, and then we'll look at some examples. It's important to know that we have this thing called rate of change. Now, what is a rate of change? Well, quite simply, a rate of change is a ratio that shows how one variable changes with respect to another. We'll see if I'm able to fit this all on the line. How one variable changes with respect to another. Well, that's pretty close, isn't it? A ratio that changes, that shows how one variable changes with respect to another. Remember, ratio basically means a comparison, or mathematically speaking, a fraction. So we'll see a lot of fractions today. So on a linear graph, though, this is called slope. It is called the slope of the line. That's really the key word that we're looking at. So if you wanted to know what slope was, it's basically a comparison of how one variable changes when another one changes. How do we write slope? Well, like I said, it's written as a ratio. And what that means more often than not is just a fraction. So we will write this as a ratio of the vertical change, or we call it rise, to the horizontal change, run. So it's a comparison of the vertical change, rise, to the horizontal change, run, between any 2 points on the line. This remains constant for any 2 points on the same line. Now what does that mean? It means it doesn't change. Constant means it doesn't change. Same thing if I'm like pumping gas at a gas station. The cost per gallon is not going to change depending on how many gallons I buy. It's always going to be $2 per gallon. So slope, like I said, is written as a fraction. It's written as a fraction in simplest form. We want to get it down to its most reduced value that we can. And the variable that we use for this slope, or this fraction, is quite simply m. It's a lowercase m, not an uppercase. And really, we're going to be looking at how to find this. And I'm going to see if I can't increase the size, because I'm figuring out as I go on just how kind of weird this is, how kind of awkward. Now, it's important for us to know that there are 4 types of slope. There's a slope that goes like this. It's not quite supposed to be like that. It's supposed to be a straight line. But this is a positive slope. Right? I'm going to see what I can do to change this up just a little bit. I'm not liking how thick this is. That's a positive slope. And then, of course, to counter that, we have this kind of slope, which is, of course, negative. And we'll have ways of talking and describing these later. Talking and describing them. We can have a straight horizontal line, which we refer to as zero slope. That's when there's all run, no rise. Notice that the change is completely horizontal. There's no vertical. And then likewise, just as we can have something that's all horizontal, we can also have something that is all vertical. Now this is the weird one that we call undefined. I have to make sure I have to spell this correctly. Remember, I like to joke. I'm a math teacher, not an English teacher. So we have our 4 types of slope. And we're going to go through the first 8 examples. I'm not going to go through all the examples from this rates of change piece. We will skip a few because I don't want to take up too much time. But we're going to practice this out. And I think I'm going to try my red pen now. We're going to practice recognizing slope and finding it from a graph. So it's important to know that finding slope on a graph, remember that we said our m, or slope, is rise over run, right? Because we put this in a fraction and we simplify it. So we are going to look at these graphs and we're going to try to figure out what the slope is based on the points. And the nice thing is, with number 1, I see there's a point here and a point here. Notice that what you're trying to do up front is look for points that you can use. These are on grid points. Notice that they're on lines that intersect like that. So we know we've got these points. Now we need to think about the rise and the run. Remember what rise is. Rise is the vertical change. We always want to start with that. And I'm going to start with, I'm going to write my m, and I'm going to equal that to a fraction. Okay. So we want to see how far up or how far down we went, right? Well, look. 1, 2, 3, 4, 5, 6, 7. Notice that we went up 7. Now that's a positive 7, right? Because we went up. It's always an important thing to remember whether you're going up or going down, because that'll tell you what your sign is. We went up 7, so that's positive 7 right there. And I'm gonna draw my little line that says, hey, that's a 7. But then we also have to calculate run. And remember that run is the horizontal change. So I have to go from this point here over to the other point that's on the line, which means I'm going over 1, 2, 3, 4. Now I went to the right 4. And on a number line, the farther we go right, the more we go positive, right? Isn't that correct? That means that this is a positive 4. And I put that here. So I have my rise, which is my vertical change, in the top. And I've got my run, which is my horizontal change, in the bottom. And I can't simplify 7 over 4, can I? No, they don't have a number in common other than 1. So that's where we are left at. Okay, so then example 2. Let's try this again. Remember that we have to locate our 2 points. Now these aren't always going to have dots, so sometimes we might have to get creative. And that's okay. We can figure that out in time. But just be looking for those grid points that intersect on the line. Remember what's first? I have to calculate my rise, or my vertical change, right? Well, did I go up or did I go down from this point to this point? I hope you're saying down already. How far down? 1, 2, it looks like 3. Am I right? 1, 2, 3. Good. That's a total of 3. Now, I went down, though, didn't I? So is that positive or negative? I hope you're saying it's negative. We definitely went down, so it's definitely a negative number. As far as run goes, how far over did we go? 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at that. We went to the right 9, meaning that's positive. So I have slope is equal to negative 3 over 9, and we want to simplify this. We want it in the simplest form that we can get. So what's a common number between 3 and 9? Hopefully you're saying it's 3. So I can divide out a 3 there. Negative 3 divided by 3 is negative 1, and 9 divided by 3 is just 3. So our slope is negative 1/3. And I'm hoping you're seeing that that makes sense because it's a negative slope. We are going down from left to right, so that makes sense. As for number 3, well, if I look at this, it's already easy to see. I hope you're saying, hey, that's a straight horizontal line. I can look back up to here and say, hey, that's a 0 slope. Now, if I ask you, why is that a 0 slope? What makes that a 0 slope? Remember, it's because it's all horizontal. There is no rise. It's all run. As for number 4, I look at this and, hey, look, it's a straight vertical line because the points are straight up and down, which I can look back up to here and realize that's an undefined. And whenever you get stuck on this, remember, all you have to say when you get stuck, why is it undefined? Because it's all rise and no run. Make sense? Well, let's try a few more just in case you're not quite there yet. Okay, so number 5, I'm going to go back to my blue because I like blue. Again, it's about finding the 2 points that we can use to calculate this. So it just so happens these points are brought out. Slope is equal to rise over run. I want you to remember that. That is a very key idea that we want to remember. Slope is rise over run. So I need to find the vertical first, and I know that I go up 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. I have to double check. It's okay to double check. I went up 5, so that's a plus 5. And then I went over 1, 2, 3. And since I went to the right 3, that's plus 3, so I have 5 over 3. And is there a way to simplify that? Well, hopefully you're saying, no, there isn't. Because 5 and 3 don't have another number in common other than 1. So that's not going to simplify any further. 5/3 it is. And so we just follow this idea out. If you're working ahead, that's fantastic. Keep on going. Number 6, same idea. Find my points and start calculating the rise over the run. What's my vertical change? Well, look, I'm going down 1, 2, 3. I went down 3, which means it's going to be negative. All right, and then how far over did I go? Look at that. I just went over 1. Since it's right 1, it's going to be a positive 3. Now, even though this is in itself a simple form, it's negative 3 divided by 1, we can actually simplify that to the whole number. So that's just negative 3. I hope you saw that. That's definitely something we can do. Whenever something can be divided and brought down to a whole number, do it. It's definitely something we can do. It's not like it's an illegal move. Number 7. I was looking at number 6. I meant number 7. Time to do it again. What is my vertical change or my rise? Well, 1, 2, 3, 4. I went up 4. So that means my rise is 4. And then look at this. How far over to the right did I go? That looks like a 2. So it's positive 2 because I went right. Put that under. My slope is equal to 4 over 2, but guess what? That can be simplified. 4 over 2 is just 2. Last but not least, number 8. Once again, pulling off my dots. Now I need to calculate rise first. Remember, rise goes on top of my fraction. Vertical change. Where did I go? Did I go up or did I go down? Well, it looks like we're already saying down, so 1, 2, 3, and 4. I went down 4, which means that's negative. And then from here over to the other dot, I went right 1, 2, 3, 4. Ooh, I went right 4, which is a positive 4. So I have negative 4 on top, positive 4 on the bottom. Guess what that reduces to? Negative 1. And it actually works. If you look from this dot to this dot, that's actually a grid line. There's one there, one there. So the average is we're going down 1, right 1. That's important to figure out. So hopefully you've got a simplistic idea of how easy it is to find slope from a graph. If you want to try numbers 9 through whatever else there is, you're welcome to do so. I'm hoping that you've got this figured out. If not, remember that you can always email me. But always start out by finding your 2 points, working your way up or down, then left or right. So let's continue on. Aside from looking for slope on a graph, we actually have a formula. And I want to point out this fact here. The slope formula, and I call this key, the slope formula is used to find the slope between 2 points. That is important to know. It's not whether or not we've been given a graph. Sometimes we're just given 2 points, as you see in like example 1. And it's important for you to know that there's a way that we can calculate slope given just the points. And it goes like this. The formula for this is as follows. We take our second y-coordinate, such as we see in this example up here, and we subtract the first. So we take these two and we duke them out. And we're going to do the same thing with the x's. x2 minus x1. Whoop. Now there's 2 reasons why we're doing what we're doing. First of all, we focus on the y's because the y-axis is our vertical axis. So the y-coordinates tell us how far up or how far down we go. Same thing with the x's. The x's are on the bottom because those are the horizontal coordinates. Make sure you're being very careful about this formula. I've seen people mess it up time and time again, and if you don't pay attention and get it down the first time, you're going to get it wrong. And I'm just saying that to encourage you. Take your time, realize what is x1 and y1, realize what's x2 and y2, and set them up correctly. Now, if you're wondering why we're subtracting them, it's basically finding the distance. We are finding the difference in distance between the 2 y-coordinates and the difference in distance between the x-coordinates. This is what helps us calculate the change. This can be both simple and difficult depending on how you understand this. I feel it's important, I'm going to change this up just a little bit. It's important to realize that we need to label these points. We're only going to try to do examples 1 through 8, and we will try and get you moving on to the next thing. Again, remember that our formula is y2 minus y1 over x2 minus x1. Now, all we really need to do for these points is label them. I can't make this up as much as I can. I can't make this up. This is so easy that it's hard to screw up, but people still do it. Okay, notice that if I cut this down, I have my first coordinate right here. So that means that I have my x1 and my y1, right? Because these are how points go, right? Coordinate points are x comma y, right? Hopefully you're familiar with that. And that's not supposed to be a negative. That's just in there on accent. And I managed to erase the whole thing. Look at that. That's how coordinate points are. So we have x1 and y1 because this is the first point, or I should say point 1. Same thing goes for here. This is point 2. So we're able to label these x2 and y2 because we still have our x comma y. Labeling these is half the trouble. Once you label these, it's as easy as plugging this stuff into the formula and you doing it in a calculator. So let's see. Slope is equal to, if I plug in now, y2 is 3, I'm always subtracting. y1 is 1. Then I've got my fraction. x2, like I see in the bottom, is 4. So always subtract. And then x1 is just 1. 3 minus 1 is 2. 4 minus 1 is 3. 2/3. And I know that's the final because I can't simplify that anymore. 2 and 3 have only one common number. That's 1. Now, trying out number 2, we're going to move a little bit quicker because now we have this idea down. My first point is this -2, 4. That means I've got x1, y1. My second point is that 10, -2. So I've got x2, y2. Now all I have to do is plug these in. So slope is equal to -2 minus 4 over 10 minus -2. Now remember, the way I'm doing that is I'm taking these coordinates and referring back to my formula. Remember that you're always subtracting. Always focus on the fact that this is subtracting. So -2 minus the 4, it's 10 minus the -2. Now obviously, I already know what you're thinking. -2 minus 4 is -6. In the denominator, I've got a minus negative. So that means that this is going to become 10 plus 2, which is 12. Then you just need to simplify that further. And to do that, I'm going to figure out what's a common number between 6 and 12. Hopefully, you're saying 6. So -6 divided by 6 is a -1. 12 divided by 6 is 2. And so I have my slope, which is -1/2. Whew. Moving on, looking at number 3, trying to pick up the pace just a little bit. We're almost halfway there. Number 3 says -4, 5 and -8, -5. Well, let's label these. Here's my first point, so that means that's x1, y1. This is my second point, so I say x2, y2. Now plug these into the formula. So I have -5 first, always subtracting the first y coordinate, so 5. Then I've got -8, always subtracting, and then the first x coordinate, so -4. Oh, look, that's going to be a plus. That's going to be a plus. But I think you already knew that. -5 minus 5 is -10. -8 plus 4. Ooh. Well, -8 plus 4 is going to be a -4. Would you look at that? Now, because we have the negatives here like we do, a negative divided by a negative is going to make a positive. So that's going to cancel out. And then I've got 10 over 4. Well, the common number is 2. So if I take 10 divided by 2, I get 5. And if I get 4 divided by 2, I get 2. So 5/2 it is. And this is the process that we are going to use as we continue on. We might skip 6 and 7, just because I think you're going to get this real quick here. 10, 0 is 0.1, so that means I've got x1 and I've got y1. -2, 4 is my second coordinate, so I've got x2, y2. Plug it in. So m is equal to y2, which is 4, minus y1, which is 0, divided by -2 minus x1, which is 10. Okay, so I've got 4 minus 0, that's just 4. -2 minus 10. Ooh, -2 minus 10, so we're going further. I can just subtract that away. -12. Well, those have a number in common, right? It's 4. So if I divide 4 out, I'm going to get 1 over 3. Now, it's important to remember that I had a negative there, so this is -1/3. Hopefully this is making sense so far. We'll just do 5 and 6, and we'll call it for the time that we have. So, notice again, first point, second point, x1, y1, x2, y2. Plug it in. My slope is equal to 9 minus 9 over 3 minus 5. I like where this is going already. Look at this. 9 minus 9 is 0. 3 minus 5 is negative 2. Okay. Now in this case, remember, the slope here is going to be different because we've got a 0 over negative 2. Now, 0 divided by anything is 0. But what this tells us as well, remember, the fact that there's nothing on top, but here, means that this is all run. It's all horizontal. It's a horizontal line. So therefore, this is a 0 slope. Make sure you're paying attention to that. It's not just 0. It's a 0 slope because this is all run. Now it's going to be absolutely crucial to think about number 6 in the same capacity. Here's point 1, so I've got x1, y1, and then point 2, so x2, y2. I have a feeling number 6 is going to tell us something else. So slope is equal to my y2, which is 5, minus my y1, which is 8. Then that's over negative 7, which is my x2, minus my x1, which is negative 7. Pay attention to those negatives because we are always subtracting. And if we have a negative number here, you know what that means. It's going to become a plus. 5 minus 8, well, that's a negative number. That's negative 3. Negative 7 plus 7. That is so crucial. Negative 7 plus 7, 0. This, notice this, there's no run. That means this is all rise. And all rise means this is undefined. Do be careful for those. Do be careful for those special types of slope that are going to stick out like a sore thumb. They really will. As far as the lesson goes, I think that's going to be it for us today. Don't just sign off just yet because remember, we're doing virtual learning, which means I want to tell you about the homework. Homework is just based off of this. You don't have to do 13, 14, or 15. We're not worrying about those. You also don't have to worry about 10, 11, or 12. If you want to do those for bonus points, I will definitely let you have those. But the important thing for us here today is to practice, pulling slope from a graph, as well as get some practice in calculating using the slope formula. So that's all you have to do for homework is 1 through 9 on this homework 1 slope. Hopefully that stands out. And you know me, I couldn't help but do it. Your meme of the day. The person who grew up expecting to be the chosen one learns that they're meant to destroy the world, not save it. And of course it's Christian Haydenson playing Anakin Skywalker from Star Wars. So I hope this lesson makes sense. Of course, you are always welcome to email me with questions. Our Google Meets will be on Fridays from 1 to 2:30. If you have any further questions for me, you know what to do. I'll see you all later. Have a great day.